If AN equals 2 cm and AM equals cm, what is the area of the green inscribed semicircle? Reconstruction of shape, Pythagoras' theorem, area formula of semicircle. Arithmetic and algebraic operations are used to solve this question. Solution. From the given figure, length AB is a radius r of a circumscribed circle, which equals to length AC. Also, length NB is a diameter of small inscribed circle. If we redraw the figure completely, it looks exactly as the figure shown on the screen. This shows that length AB equals length AC, which equals to radius r of the larger outer circle. Alright, locate the center O of the small inscribed circle, and let r be its radius. Length AB equals length AC, which equals to r. Since M is a tangent point, join line OM. If length AM equals length CM, then length AM equals half the length AC, which equals to half of r. The result is equals to length CM. This implies that length NB equals length AB minus length AN, which equals to larger r minus 2. The result is equals to 2 times the small r. Hence, small r equals half of larger r minus 2. It follows that length ON equals length OB, which equals to small r, as shown on the screen. Hence, length OA equals the sum of 2 and half of larger r minus 2. Consider right triangle AOM. Using Pythagoras' theorem, the square of length OA equals the sum of the square of length OM and the square of length AM. Substitute values. We have that the square of the sum of 2 and half of larger r minus 2 equals the sum of the square of half of larger r minus 2 and the square of half of larger r. Expand brackets. That is 1/4 of the sum of larger r square, 4 times larger r and 4, equals the sum of larger r square minus 4 times larger r plus 4, all divided by 4, and larger r square divided by 4. Multiply the equation by 4. We obtained an equation as shown on the screen. Rearrange terms, as shown on the screen, and simplify, so that the square of larger r minus 8 times larger r equals 0. Factorize, and we have that larger r multiplied by larger r minus 8 equals 0. Hence, larger r equals 8, and larger r is not equals to 0. The reason is that the sum of 2 and 2 times small r is greater than 0. Recall that small r equals half of larger r minus 2. Substitute larger r equals 8. This implies that small r equals half of 8 minus 2, which equals to 3 units. Therefore, area of the inscribed semicircle equals half of the product of pi and the square of small r, which after substitution of values equals half of 9 times pi in square units.